Hi everybody, I am Claudio Capobianco. I am co-founder at Snapback and head of human-machine interaction. I'm here to introduce you the sensor stack in Android and in particular in Lollipop. Then, why we do care about sensors? As developers and also as interaction designer, we could feel constrained by the way that the user has to interact with the device, basically only through the touch and the screen. Touch for input and screen for output. But actually we can do a lot of more with smartphones and smart devices. First of all, we can do we can use sensors like inertial sensor, accelerometer, gyroscope, and or also microphone to to get information about what's happening around the device, and doing context awareness, like for example do application like Runtastic or Moves. But we can also improve the user interaction using sensor like, again, accelerometer, or also proximity sensor, ambient light sensor, and this could be useful for improving the user experience in gaming, but also for particular contexts like automotive or cooking, where we cannot use the touchscreen for any kind of reason. And beside the smartphone, we the knowledge of sensors is particularly important for wearable device where the touchscreen is really small-sized or completely absent. And moreover, the Internet of Things, whatever it is or will be, the sensors are in the core of Internet of Things, and it is really important to know how to deal with them. But why sensors are so still underused in smartphones? And there are several reasons. According to our experience, one of the main reasons is the power consumption of sensor, in particular for continuous reporting, and or for some kind of sensor. And this is a real problem, because we performed a research in 2014, last year, about the main reason of power consumption in a typical usage of a smartphone. And we discovered that display, network, and processor are three of the main sinks of power in smartphones, but all other peripherals like microphones, camera, inertial sensors, and audio are a main part of power consumption in smartphones. So we will concentrate about peripherals and how to optimize the power consumption here. We will analyze how sensors work, and first of all, we will introduce the concept of batching. Now, okay, assume that we are using a sensor and we registered it to the operating system. And in this way, the OS notify us through the onSensorChanged function callback. And when this function is called, our app can perform some kind of task and operation with the received data. But in continuous sensing, like for example accelerometer, a typical value of the sampling period is 20 milliseconds. This means that we are called 50 times per second, and probably we don't need to be called so frequently, and we have to store the data, consuming processor resources and also power. We can do better than this through a new mode introduced in Android KitKat 4.4, that is the batching mode. This is very interesting because we can ask to the operating system to enqueue events in an hardware FIFO, and so we can be called when a certain amount of data is stored, and after some time, that is called the maximum report latency. And then the on-sensor change is called only after this time, and we can perform this kind of application. For example, consider that we want to write a gesture recognition engine. Probably we want to be notified only when 2 seconds of samplings are collected, and so we can set maximum report latency to 2 seconds, and we can delegate much of the work to the operating system, and it is very useful. And implementing the batching mode is very simple. Basically, you get an instance of the sensor manager from the context. And the sensor manager is the manager that allows us to control all the sensors in Android. From the sensor manager, we get, for example, the proximity sensor in this case, and using the getDefaultSensor method with a constant. And we register the listener for this sensor, specifying the sampling period, as before, and optionally the max report latency. That default is 0 if it's not specified, then without batching. Otherwise, you can specify the latency, and automatically the operating system collect data in hardware FIFO if available. This is one of the main features that allows us to reduce power consumption. Another important concept that about sensor is wake up and non-wake up sensor. This answers the question about what happens to sensor in suspended mode. That is when the screen is turned off and we are not using the smartphone. Well, what happens to the sensor? It depends from the sensor, from the type of sensor. There are two kinds of sensors, that is wake-up sensors and non-wake-up sensors. This is very important because wake-up sensor always deliver data to our application, no matter if the phone is awake or in suspend mode. And so if for example, if the processor is suspend mode, processor is waked up and data delivered. On the other side, there are non-wake-up sensor that works only when the processor is awake, and all data in all events when processor is suspended are simply lost. So it's very important to know if a sensor is wake up or non-wake up. But which sensor is wake up and which sensor is non-wake up? Again, up to KitKat, most sensors were non-wake up. Almost all sensors except for the proximity sensor and the significant motion detector. These were the only two sensors that could awake the phone. But if the developer needs to perform some operation in suspend mode with other sensors, they have to use a workaround that is to keep a wake lock on the processor to prevent the suspend mode, but the wake lock is very power consuming. So, starting in Lollipop, there is a this function is completely changed because most sensors can be defined as variants of wake up and non-wake up sensor. So we can instantiate the sensor that according to our needs, and in this way we can say that continuous reporting for all sensors is officially supported by Android from starting in Lollipop. Again, how to register a wake up and a non-wake up sensor. Starting in Lollipop, there is a new optional boolean in the getDefaultSensor manager that we have already seen before. A boolean that is wake up. In the first line, we are using we want to use a wake-up accelerometer. So we specify true as Boolean, and if a wake-up accelerometer exists, it is returned, and we can use it in suspend mode. Otherwise, this function returns null. Again, here we want to instantiate a non-wake-up proximity sensor, because, for example, our application doesn't work in standby, and so we can instantiate it if the non-wake-up proximity sensor exists. And while the wake-up proximity sensor has to exist, because this is the default, as before. So if the smartphone has a proximity, physically has a proximity sensor, the wake-up proximity sensor must exist. Now, combining batching and wake-up sensor is very powerful, because we can drastically reduce the power consumption of our application. And this is not only a matter of reducing power consumption of a small percentage, but in this way we can design and implement new kind of application, because we can design applications that are always on the phone and works always, without killing the battery in few hours, like happens just now, or in the older version of Android. But this is not simple. This is really a revolution, and involves the full stack, because for wake-up sensor and batch mode, the hardware manufacturer have to provide the hardware FIFO to allow batching, and of course the Android open source project contributors have to implement the Lollipop specification and make the bridge between the hardware and the framework, so the application developers. And finally, application developers have to use these new features and take advantage of these new functionalities. So this was a short overview about what can do. What means the optimization of sensor performances, and Google is really investing a lot of resources in it. If you can see the sensor stack page in the website, and is changed very frequently, at least once a week. So adding new documentation, new features, and really probably the future of new application will be in the use of continuous sensing and in batching mode and wake up. And yeah, I would introduce also that is founded 1 year and a half ago. We design interfaces for mobile computing. We are based in Rome, but we are active in Europe and also in United States. The smartphone have a massive penetration in our daily life, and we use them to get useful information and also to communicate. So we are willing to use them also when we would not, or we should not use them. And this is a problem, especially in particular contexts like automotive or also in cooking. But while the devices are keeping evolving from PC, laptop, smartphone, tablet, and so on, interfaces are still heavily based on touch and sight. We are addressing this problem by proposing an SDK for touchless sightless interaction that integrates several modalities in a unique framework. We integrate air gesture, like waving a hand in the front of a smartphone. Sound recognition, like the finger snap that gives the name of the to the company. Motion recognition, we have a gesture recognition engine, and also we recognize the inclination, direction, orientation of the smartphone. And we integrate external library for voice recognition, because of course speech recognition is still advanced. We use good libraries that are already available. How our SDK works? First of all, you choose a pattern that you want to recognize. For example, you could recognize a single pulse or a double wave that is something similar to the double click on a mouse, or simply want to recognize a steady event. This is a pattern. The source, the input source for this pattern, that is could be something simple like a proximity sensor directly on the sensor, or something more complex and higher level like a blow detection, or a combination of inclination, gesture recognition. There are many others input source. Now we are about 15 input source using all the sensor in the phone, in the smartphone, and also wearable. We support Android Wear. Okay, I just get notified about your listener, the on event, and that's all. It's very simple, and there are several benefits for developers, because first of all, use all these kind of sensors and input source is the same, and hide the difference of sensor inside the same phone, but also fragmentation between several phones, because sensor behave in a different way, and we take care of mitigate these differences. And most of all, interaction designer, for example, could experiment easily several kind of interactions. So starting, for example, from the usual touch interface, could add new commands based on sound, wave, or speech very easily, change them, see. They could also implement new sensor adapters to new modalities. And the best thing is that our SDK is compatible with basically all Android devices, but automatically takes advantage of the latest API features for power consumption that I presented before. Our SDK usage. This is a Sony Xperia Z1 that is our underwater phone, but underwater the screen doesn't work. So the only things that you can do with this phone is take a picture with a dedicated button. Using our SDK, just in Alpha Day, we created a camera application that could reproduce most of the function of a common camera, like swap front and rear camera, take picture, change camera application, everything underwater. And this is a typical usage of exploit the potential of a device also beyond the intention of the manufacturer. This is very interesting. We are releasing our SDK inside a premium program, using or try the SDK, or just you can apply to that Google form. Or if you want to know more about programming the sensor stack, new features of Android or whatever, you can write to developer@snapback.io.